members now. Is that everyone? No one was there anyway. Let's make a start. Okay then. Well, I hope you've had plenty of time to get a couple of coffees in you. So I'm going to use Steve's favourite word, which I meant to actually do little a, Agile. I'm starting to prefer that. That's my little statement.
Yeah. No, I agree with you. I think I'm building up to a rant. You've seen the Bertram Myers thing? What does it do?
Yeah, that was really
Very good,
interesting.
isn't it? Very
Yeah, there were a few things that I've tried and I kind of agree with his conclusions on, I have to say. So yeah, in fact, to be fair, you can rephrase this to iterative software development. That's what the real main crux of this is. So, so I'm going to talk about Agile software development, and I'm very explicitly talking about software development because whenever you hear about Agile, you hear about stand-up meetings and collaborative teams and user stories, and all that stuff only really works if you write your software in a certain way. If you plan your software up front and write it all in one go, then in theory it could be completely illegible. You'd have a hard time developing it in the first place. But with Agile development, so I've been doing this now for a year and a quarter, whilst the technology is a year and a quarter old-ish, and soon discovered that iterative development is an approach I like. It lets you work with people better, but you can end up running into problems. My favourite phrase for this is flaccid Scrum. So they describe the productivity of Scrum that kind of always droops off at the end a little bit, because if you don't make your code base in a way that you can keep modifying it again and again, you get more and more technical debt. It becomes harder and harder to actually change, and you'll find everything slows down. And the final thing I want to say is this is kind of a sharing of experiences. This is all stuff that I've just been trying and I'm reporting back on. What I'm saying is don't take this as authoritative, and I'm intrigued in the experiences that you have as well. And also bear with me because after yesterday I completely changed the order of this presentation, so I might get a bit confused, but I think it's better now. So like I say, really what I mean by Agile software development, it's writing software that's easy to change. And what I've kind of seen is it really boils down to three things, and I've noticed a few things that are very similar for Steve's slide yesterday. It's got to be modular. Modular code really makes it significantly easier to focus on the particular bit that you want to work on. And when you get a customer call, I always think this is a good sign when a customer calls up and says, I've had X problem, and I think, well, actually, I already know exactly where in my code I need to go to see what's going on. It needs to be simple to read, that's Elmo. You will come back to this code maybe 3 months apart again and again, and you don't want to have to spend a day trying to work out what you were intending to do. And the last one here is dependencies. This is an interesting one, and I can't quite decide how to broach this topic. It really means coupling as well when I'm talking about dependencies, and I'm going to try and use that word instead because I think it's a bit more relevant to LabVIEW and what I mean by it. Really the point here is if everything is tightly interlinked, it obviously makes it much harder to change module A without affecting module B, C and D. And you're going to find for every positive change you make, you could end up having 3 negative changes. I also wanted to say, I'm going to try my best to talk about modules. I use classes in LabVIEW quite a bit. There are certain things in here that I think it helps with a lot, and I'll highlight that. But equally, there are certain things in here that you can do with whichever technique you use to build your modules. So if I slip into classes, I apologise, and I'll try and emphasise where I think there is a difference. So this I stole directly from Stephen Mercer's slides. I actually found the source that I'll link at the end. So I've really got 3 big points that my development style has changed while I've been doing this. The first one is using modularity and abstraction wisely, which is a useless piece of advice, because everyone thinks that's what they're doing anyway. But and I highlight some places where this can really help. The slide, by the way, if you can't see the back, says if it looks like a duck, quacks like a duck, but needs batteries, you probably have the wrong abstraction.
I quite like the idea of time, as saying time spent at this point is actually very valuable. You'll save yourself time further down the project.
Mm. So there's a little bit of computer science and a little bit of psychology in this, and I'm going to try and keep it to a minimum. This is why I was getting so excited during Steve's presentation yesterday. Like, yes, this is the sort of thing I've been thinking about as well. I think the main thing with modularity and abstraction in your code is the point is to make your life easier. There are people that say as long as the software works, bugger the code. And there are people that say the code should always be beautiful, and I think the reality is somewhere in the middle. But erring towards beautiful code, the reason why you want to think about that is because, especially in iterative development, you have to come back fresh off of doing some other task and pick up this code and work with it. And so the point of modularity and abstraction, as much as anything, is to make it easy for you. There's a concept that our working memory deals with 7 plus or minus 2 items. That's, someone came up with that particular number at some point. I think the point is everyone varies in there, but it gives you a ballpark figure. That's why you do things like chunk up phone numbers, because you can't remember 11 straight digits, but if you have 3 groups of digits, you can remember that, which of course somehow lets you remember 11, which is not what I'm going to go into. But the point is, when you have more than that to kind of keep in your mental model, it becomes difficult, and you will drop things, you'll have to keep going back and rereading things and figure out where it is. So when you're building your software, try and keep that idea in mind. You know, if you're suddenly building a cluster that has 20 different items, it's probably time to start trying to break it down closer to that number. More often than not, the reason for, or not the reason for breaking that down, but the kind of philosophy to break that down by, is that every module should have a single responsibility. And that comes back to my statement earlier about the modularity. It's that if I know something's wrong with loading the config file, I should know exactly which module, presumably the config loader, I need to go in to look at. And I don't need to explore the rest of the code. The abstraction side comes from a nice idea that I've never seen it explicitly used in these terms, but it was something, a discussion point I used a lot when I had, I'm going to refer to my JavaScript contractor as I have done quite a few times through today and this weekend, because we had a lot of discussions around this, and he was the one that put this idea in my head. And the idea is that you're always working at different levels of abstraction when you're in software. You know, obviously none of us work in machine code anymore. But if you have software where you're switching between maybe very detailed work and very high level work, that's effectively causing you to kind of task switch a bit, and it's a bit harder to comprehend what's going on. I sort of have an example of this. This was a bit inspired by discussions yesterday, and it doesn't work perfectly, but bear with me. So this is, and I'm going to name and shame some of my own code in this, but hopefully not shame, I've got some nice examples later. This is an example, and actually you may recognise it as being based off one of the template projects. And this was a project I did very early on for a customer who wanted to pick up the code himself, so we said, okay, we'll keep the concept simple, we'll start from a template so it's well documented. I wouldn't necessarily recommend it. But this is part of the code where we have, this is inside a queued message handler, and it's going to get a message to say broadcast settings, and then it's going to send update settings to someone, send update settings to someone else, and send start background to someone else. And the reason I say it deliberately awkwardly is because that doesn't really mean anything to us. Why are we dealing, you know, when we're thinking at the level of, I have a process that needs to do this thing, I don't think we should be thinking about the fact the way we get something else to do something is we have to send it a message using a queue using this API. And my argument would be for there should actually just be a VI here. So one of these is the DAC process, for example, that says update DAC settings. And that level should be hidden from you at this level. It's not, it's not the best example, and I've got some more examples of it done well, and hopefully that will help push the point home as well. And actually, when I was thinking about this, so in a lot of web development, they enforce a very strict layered approach. And I don't want to go strict, but I was trying to think how this applies to LabVIEW, and I think it kind of can. Level names and number of levels are all optional, but I was trying to think this through, and I think this very often in a lot of my applications, I actually end up with these 3 levels of abstraction, and I try not to mix them in one diagram. So I'm going to have my top level kind of process stuff, and this should really read like a flow diagram. It should be reading like, I want to acquire some DAC data and I want to log it to a file, and perhaps I want to send something to another computer. Then you get what I've called the model layer, which is a bit of a CSE term that I don't like. But what I'm really talking about here is this is where you get your kind of, well, modules and very specific items to the task that you're doing. So I might have a configuration loader, I might have a data acquisition system, I might have an alarm library. They're your building blocks of your application, but very specific to the application you're working on. These are then going to deal with the lower level APIs, things like I want to use a JSON file, I want to use DACMX. But this model layer, I think, does 2 things. It helps you, A, work at different conceptual levels. So as long as you're working at this level, all you want to know is you start your DAC. You don't really care what calls into DACMX are being made at that point. But then down here you do. And it allows you to work at an appropriate level. This is a work in process. I only came up with this structure the other day, but I kind of liking the concept. So this is a project that hopefully I've anonymized, and if you see a name, just ignore it.
Looking for. Shouldn't have said that.
But this is what I started a few months ago, and I'm kind of looking back at it and thinking I'm quite happy with the kind of structure that I've got. So I'm using objects, which is why I have nice colourful wires.
The other wire.
Yeah, I tend to avoid them and the light green because they don't turn up, but I was perhaps feeling a bit neon when I started this. And this really illustrates what it is. So to give you an idea, this is a scalable alarming application. So we can have one of a number of different I/O components that can be loaded dynamically, and they can generate alarms into an alarm engine and send those back to a server. So my layered approach says this is my application layer. So at this level, I can see I've got a state machine. I can see I'm going to initialize. Ignore the first 2 because it's too complicated. Run and shut down, and I can see my different modules and how I interact with them. So I've got a status module, an alarm module, an interface module. So at this level, I can very easily manipulate kind of the overall application flow without having to get into the nitty-gritty of how these processes work. I think about this as well. There's no framework stuff. That's all hidden away behind the APIs. There's some that exists, and we'll see that as we go down, but it gives me a very clear view of how the application runs. Then if I am more interested in something like the alarming, so actually these do still run as parallel processes, and I can dig into the alarm process. And this is kind of my middle layer, really. They are still QMHs, but when I want to raise an alarm, I've hidden the QMH behind an API. So the other processes just have a raise alarm sub-VI. They don't know how that's being raised or where it's going. And again here, so this is my alarm storage, which isn't fantastically clear. So I'm working with that at another level, and behind that is my SQL statements. So again, I can manipulate how alarms work without dealing with how they're stored. So I wanted to show something that I've actually worked on to try and illustrate this point. And again, I'm not advocating that you have to absolutely follow 3 layers, and in fact, to be fair, there's sort of 4 in this one anyway. But think about actually by hiding the details and keeping an appropriate level of abstraction at each level, we can think at different levels of application. And again, when I find out there's a problem because an alarm isn't always raised, I go to where the alarms are raised. When I find there's a problem because there's a storage problem with the alarms, then I dig into that object. And I don't have to care about the rest of the application. Oh, sorry, it's going to be like that. New PowerPoint is too clever. So number 2 is thinking about dependencies, and like I say, I'm sort of undecided on terminology here. So say dependencies, say coupling. Either way, the point is here, think about how different parts of your application are tied together. I actually think this isn't as big of an issue in LabVIEW as it is in other languages. You often hear about, oh, I have to, rebuild this section if I have to rebuild this section. Actually, LabVIEW, things tend to propagate a bit happier and require a little less work. Nonetheless, every time a bit of code changes, there's a risk of problems. So we want to minimize possible knock-on effects. The thing that's really got me is type defs. So I have an example of this, and this has specifically happened to me a few times. Let's say, and this is a bit contrived, but let's say our DACMX API returns a DAC data type def. So we have some data back from that, and that's a type def. And obviously, at some point, our alarm needs to see that. So we go, okay, we write our DACMX library, we pass that back through the DAC system, that ends up at the application, we pass that over, and now all of a sudden, my alarm library is dependent on my DACMX library. The fun test of this is to pick one of your modules and load it, and just see what else loads. It's amazing how many times everything else loads. And it's normally just because there's one type def or one kind of link that's tying things together. And I guess it's particularly a problem with classes and libraries.
Don't see that. So that must be a...
Yeah, actually, to be fair, because it will load everything with it.
Yeah. I'm just becoming interested in classes, in that, how it loads everything.
So I've noticed that a lot, and this is a CS term warning. The solution, as defined in some of the kind of recommended routes, is something called dependency inversion. The problem I have there is I have a lower level object, module, call it what you will, my DACMX library, and my higher level libraries call it. So they become dependent on that. And that's kind of how that's managed to travel through the layers. There's a concept, and I'm kind of playing with this, and I like it so far, and there's another benefit to this that I'll talk about later, called dependency inversion. What this says is you sort of invert the way you're looking at it. So instead of package object A saying I need an object B, object A says I need something that matches this interface. So that's what that is dependent on, and then object B defines that interface. It fills in the gaps. So this never knows it's actually calling object B. This is where OOP helps a lot. This is very difficult to do without it, because it involves some of the dynamic dispatching stuff that we saw yesterday from John, wasn't it, talking about that. But it does disconnect these different parts of your application. So this is one of the reasons I think it helps as well, is because it builds in a level of translation specific to your application. So if we look at the same case, we still have our DACMX function, and that still returns DACMX data. And by the way, this layer, the reason why I think this needs a distinct layer is this is forced upon us. This is reuse code. We don't get to say what the API is for DACMX. We're given an API, so we have to work with that. But if we reverse it, what we then say is, actually the top level says, this is what data needs to look like. For this application, this is the most useful format for data. Which means that our middle layer must return that format and must consume that format. But obviously that doesn't work at the bottom, so this middle layer ends up doing some translation on that. And what happens is it starts to decouple the layers. It stops them being dependent on each other. It also has some nice side effects of, actually you can make these data types much more relevant to what you're doing. I think it makes it easier to understand the problem at hand. It can be seen as wasteful, if you've got unnecessary conversions going on, but I think it was Steve and someone else yesterday, computers are pretty powerful now. Even the embedded compact readers have got 256 meg of RAM. We can afford to lose a few more bytes on doing this if it makes our life easier. So that's number 2. I have got an example of that actually, before I come on to my next secret topic. So I actually do that as part of my server interface. So I have a generic server interface that my alarms process and my status process have. And then at my application level, I say, actually, I want this to be a HTTPS interface, and I pass that in. It's a technique called dependency injection. It's different from inversion, very badly, similar names. But this then allows me to kind of decouple the fact that there's any HTTPS going on from the application. So if I need to change it, it's easy to do. If I need to test it, it helps as well. That's where your kind of abstraction layers come in, your hardware abstraction. But the difference here is it's looking down. It doesn't say, what does a DMM API look like? Let's make a generic one. It says, what does this application need? Now fill in the gaps with the APIs that we've got. I don't know if that makes sense. That's my my main thing that I've started thinking about it. I'm trying to think of a nice, clear way to explain it. But I think that's the important thing, is it's you define the interface that you want from the top level, not what you're given from the bottom level. So my final thing is unit testing. I love unit testing now. I'm willing to stand up and say it. I've had a play, I've done it in lots of different ways and with different tools, and I feel like I've got something now that works. There's still no brilliant tools in LabVIEW, but we can make them work. So the first struggle I had when I first started hearing about unit testing again is actually a definition of unit testing. So I was taught, I don't remember by who or when, or maybe I invented it, but I had an idea in my head. Integration testing takes multiple VIs and makes them talk to each other and make sure that works. Unit testing takes one VI and you give it some inputs and you get some outputs and you make sure that works. Which was true at some point, but the term has kind of moved on. And the nicer term, I think, now is it tests a unit of work in your application. So it's not necessarily one VI, but it's one task that your application does. So, let me show you in that project. So I'm using VI Tester at the minute from JKI. I've stood up here and said how wonderful I thought unit test framework can be, and I've come to the conclusion it's never going to get to as wonderful as I'd like it to. VI Tester is slightly less painful, though it has its own issues, which I'm not going to go into too much detail now. But it helps a lot with the objects as well. So the downside to object-oriented programming is, as kind of to Steve's point yesterday, is we can't take a single VI often and run it because we have no way of initializing the object inputs in LangView. Even though they're functionally the same as a cluster, it's an ability you give up when you go to the object-oriented programming. So there's normally a bit of setup. The conclusion I've come to is actually for some of this unit of work stuff, it's going to be anyway. So I had a good example here somewhere. So let me show you one. So I don't have huge coverage here, but I have been kind of filling in some of the blanks as I've discovered this a bit more. So this is a VI to test the alarm process and test running, raising an alarm. And this is what I mean by kind of a unit of work. I'm not just taking one of my VIs and saying, oh, it goes through without an error. I'm actually letting it go through its whole kind of function flow. So it's obviously not very clear on this screen. What I've got here is I've got an alarm process, so I'm running my process here. I've got the way I've done the stop control in this, and I've still not settled on this as a nice pattern, but it's the way I've got it, is I have an application object, which then here I can send a stop command to the process. And then here I have, this is the alarm process API for raising an alarm. So in here it's going to enqueue what we need and fire it off to that process. And the way I'm then testing that is using something called a spy, which is basically a test object. So I had my HTTPS implementation of the server interface. I can have another one that I can replace that with, which is a test interface, and I can see that that's been called and what it's been called with. So what I'm doing here is firing off an alarm, making sure it's had time to be processed, because it's obviously a QMH, so you don't really know when it's finished. And then I'm checking that test object and saying, were you called, and were you called with the right parameters? So that isn't just testing one VI, that's testing that when we call this API, obviously it's being enqueued, it's being dequeued here, and it's deciding to call the interface at some level. I was unsure of whether to use this as an example. I hope it kind of makes sense. And certainly it does highlight the unit of work thing as opposed to a single VI.
You have to have everything working, everything running when you have a program running.
No, so this...
That fire off set up the asynchronous process and then send it the...
Yeah, so this is actually my asynchronous process here, this VI here, yeah. There's a bit of initialization happening back here, so you can have a setup VI.
Yeah, that's what I was going to suggest. It might be worth if you sell the initialize at the tier down.
Yeah, that's the bit I'm missing. This is a standard thing with the JKL.
Yes.
Yeah, so you separate, so you can do that once and then you reuse it.
Steve, you will always run the setup and the tear down for each of the tests.
Yeah.
And if you have like multiple tests within a test case, it will do it for each of the tests. The test within the test case. I don't know if you understand what I'm trying to say.
Yeah.
Yeah, so what's happening before all of that is I'm just doing my setup. So I remember what I'm doing. Oh, so the other thing this is actually doing is it's doing storage as well. So I'm just finding my database, existing temporary database, and deleting it so that I don't have any existing state. I'm creating my test application object, so that's the one that was being used to start and stop it. I'm creating my test server interface and then injecting that into the alarm process. So I'm telling it, here's the server interface you're using. If I was just had the HTTPS linked in here, then I could never test this. And so this is the challenge with the object-oriented programming, and the benefit is it's harder to test, but we can do some more interesting testing. Does that make any sense? And then let me show you a simpler one, because I actually, when I was prepping for this, and this is why I love it. So I was on site on this project the other day, and I was mucking about trying to get a serial interface working, And then I came back to run my tests to check this demo was going to work. And you can see the bar's gone red because I've actually broken something. And this is the other reason I like unit tests, is you get this ability to go, oh, something's gone wrong with loading the Modbus settings. So immediately I'm getting good feedback on where a problem is. So this is a slightly simpler test. There's no setup. You can see here I'm just loading some JSON, forcing this to load, and then I'm just checking the configuration at the end.
It also tells you the time it takes to run the test. So if you want to verify how fast you run a task or something, you can also see it there, because in the report you can see the time it takes to run the test itself, so you can make a guess of how quick it is or not.
It depends on how much you've got going on.
Yeah, exactly.
Yeah, and you'll notice the main reason I use the JKI one is it is significantly faster than NI's one, because it's also doing code coverage. This one you could start to do some sort of evaluation with that. But if there was a specific specification, you could test it. You could put some benchmarking around it as well and test for that. So that's, I should have asked before, how many people have seen unit testing before? And have you come across the concept? So it's quite new. So I didn't really have time to go through it in great detail. I'm going to talk about the benefits, and it's definitely worth exploring and understanding a little bit more.
You've got a video, haven't you, on your website?
Yes, so I've got a little one with the unit test framework. That's why I feel a bit dirty coming and talking about the JKI VO testing, because I was talking about that so much. That's my last demo, so I'm going to just leave it in this mode. Oh no, it doesn't work, does it? So that's kind of how I'm using testing. I've read a lot and come across a lot of different terminology and a lot of different, frankly, churches would be the best way to describe them, about testing. People get very passionate about this. Some of the things I've tried and that sort of didn't work, or to highlight some of these terms, test-driven development is the big one that you'll see, or TDD. This has some nice ideas. The basic idea behind this is you go through what they call the red-green refactor cycle. Red means you have a failing test. So before you do anything, you write a test that fails. Then you do whatever you have to, break every rule in the book to make that test pass. This is in the purest form. And then you refactor that into a nice solution. The other thing this kind of advocates, but actually in real life I haven't found anyone that says this actually holds through, is it sort of suggests you don't have to do any design work. If you take a requirement and turn it into a test, your system will somehow evolve into a lovely design. And I tried this on a little sub-project. Just don't. It's not true. And everyone I speak to who is an advocate for this will say the same thing. It works in nice contrived examples in books. And to be fair, I should say, so there's a guy called Kent Beck, who is kind of the leader of this church, if you like. He kind of wrote the book. And it's worth looking at because it's short and very practical. But even he will, he's not someone who is too worried about putting his hands up and saying, some of this stuff I wouldn't do in real life. The other thing he says is, I'll take the assumed answer. I won't always go through every single step. I'll go, I know where this is ending up, I'll jump a few steps. The thing I do like for this is the test first idea, and I actually do this regularly now, is before I write any code, in LabVIEW you still have to build your APIs first, because you can't just start typing like text-based languages. But I will write a test that tests what I need it to do, and it fails, and then I will write the code to make it pass, which has two major benefits that I've found. The first is, if you don't make a test that fails first, it means you don't know that it's your code that's made it pass. It's easy to write a test and then realize you're testing the wrong thing, and this just validates some of that for you. The other thing is it's a nice psychological tick, I don't know if that's the right phrase, is maybe every half hour, every hour, depending on how much you break the application down, you get a nice little green box that says, yeah, you're doing well today, you're getting through it. It's not quite as exciting as the I've done 5 days worth of code and now I'm going to see if it works, but it's a bit more reliable. Integration testing I kind of already referenced. This suggests that rather than just testing software, you're bringing in some outside elements like databases and stuff like that. I'll talk about in a second. It's a bit harder, basically, is the problem, because you've got external state to deal with. Databases and files you can normally work with. Stuff like DAC hardware, you know, that would be a very hard rig to set up and would probably not be worth it. BDD is behavior-driven development, and really it's really the same thing as it was originally set out as test-driven development, but someone wanted to make it more explicit that we're testing behaviors. And the reason for that is behaviors don't really change unless requirements change. So if your application is supposed to raise an alarm when you call the raise alarm API, that isn't going to change over time. If you've decided how you're going to raise that alarm is to put it in a queue and have a separate process, and then you decide, actually, I want to get rid of that, that's more likely to change, and that's where you get people complaining that tests break all the time because I'm changing how I've implemented something. So you want to test the behaviors rather than the implementation, because it tends to mean less rework of the tests. It also means that the tests are a bit more valuable. So I've covered a whole load of kind of individual units of software in one test, because there is an overhead associated. So you get a bit more bang for your buck. Right, how am I doing? So, in hindsight, this might have been better in a different order. But the reason why I stand up here and say I'm going to continue doing unit testing is, the first thing is it's obviously just nice to have some extra confidence in your code. I can fairly confidently go on site to a customer now, you know, if I haven't had the hardware, knowing yet something might still go wrong with the hardware interface, or there might be some funny timing issue, but I know, you know, if I add two numbers together, I'm going to get the right result. I know the core of my application is functioning and doing what it should do. And every time I change it, I can rerun those tests and kind of revalidate that. The other thing I really like, and these two are kind of a bit more related, is it helps you with breaking down the problem. It forces you to be more modular, because you think of tests in that way. You think, oh, I need to send an alarm to the alarm processor, or you think a bit more in that sense. And I've got a nice example of this. It wasn't this Monday, for everyone that knows I was on my stag do that. But last Monday, it was the end of the day, I was a little bit tired. And I've got another existing application, a data acquisition application. It's relatively large, it's a project that's been going on for a couple of years, and we wanted to add some system calibration in. So storing some calibration constants, loading them and applying them to the measurements. And actually this system isn't so simple, because we have to apply those in a few different areas of the system. And I'm not going to lie, I was a bit tired, and I was just walking in. I tend to pace when I'm thinking, and I was just walking in circles going, I don't really know where to start. You know, I had blank VI syndrome really. And then finally I gave myself a boot and said, well, what you're supposed to do is like, right, start with the tests. So sat down and said, I need to load some calibration constants for a file. And that simple act of just breaking out the individual elements, I find makes it a lot easier, and I spend less time pacing around trying to decide what to do next or where to start. It helps to break the problem down into pieces, more manageable pieces. The other thing that's interesting, and especially if you're on a multi-developer team, is it acts as a form of documentation. When I've been working with my JavaScript developer, we'll hear more from him on the next slide, when I've had pieces of code that aren't working, I can go back to the tests he's written and see what he was thinking. What was he intending it to do? Am I using it outside of a use case, or has he just not tested the use case that I was thinking of and not considered it? So it helps to go back and understand. It's just another way of understanding what you were really intending the code to do. That doesn't mean it's doing the right thing, but it means that's what you intended. But I will stand up and say this is not everything. I'm not going to go back and say I I'm going to fully test everything now, and I will never have any problems. There is overhead associated with this. Most common knowledge of people, once you get through the initial kind of pain barrier of getting used to the workflow and used to the tools, is that it does pay off. But there is a little bit more payment up front for hopefully benefits when it comes to things just working and not having to be debugged and things. Also, your code, you can only be as confident as good as your tests are. So this highlight here is now I'm going to pick on my developer a little bit. He was a good developer. It's just easy to pick on because he's not here.
No, typical contract.
So what I'm highlighting here, so this is the coverage summary from part of the JavaScript application he was working on with me. And it was pretty well tested. By and large, these numbers are around about 90%. So about 90% of the code was called in a test somewhere. But as soon as he left, I found two problems. The first one was with a database. For those of you that know a bit about databases, it was a collation problem. So the dev database was different from the deployment database. And what I'm saying with this is you cannot test much integration, or integration will always be a problem. And actually, probably you'll find the biggest problem more than what the unit tests really cover. There are things you can do to avoid this. You either need to make that bottom API level really thin, so you can test all the way down purely in software, or some things you can test. So on one project where we're putting data into a database, I'm kind of not as worried about pulling data out, because at least we haven't lost any data. But I'm really paranoid about putting in incorrect data, because it's gone then, if it's wrong. So what I do there is I set up a test database with a known state so that I can run tests against it and I actually do some integration testing there. The other thing is, as I kind of said, your code only tests what you write it to test. So the whole principle of 100% code coverage only works if you put in the kind of right tests. You could hit that number, but just never actually assert that any tests pass. But you've got 100% coverage, so everything must work. Which is why I don't normally track this. I don't see a point in it. It's kind of a false crutch, I think. The example of this was we had some logic in this application where you can either get data from a live data source or from a database data source, a historical source. And so we wrote some code to switch between the two, depending on what's been requested by the user. And in short, it doesn't work in a concurrent system. I spotted this as soon as I looked at how he'd written the code, but because he hadn't considered that, he hadn't written a test for it, and so from his perspective, it all looked okay. So testing can give you confidence, but just be careful about getting a bit cocky. So I think that was all I was going to say. I feel like I've missed something I was going to say on testing, but I can't remember what it is. I hope that was useful. Like I say, I know I haven't got into too much detail. I sort of wanted to just share some of the things that have worked and failed for me, and give you some ideas of stuff to look into. Some further reading. I think I did quite well on this. I had a dream of bringing in some principles that I hate the terms for because they sound all complicated and horrible, but actually are fairly sound underneath. And they're called the solid principles. So the only one I actually put the name in for is dependency inversion. That's one of the solid principles. Single responsibility is another one. That's the S. And there's three others that I'm not going to go into now. They're from a book called Agile Software Development by a guy called Robert C. Martin. I've kind of flicked through bits of this. It does break it down quite nicely and give you some quite practical examples. And it's kind of the original source for those solid principles. So it's a good book. Quite a few people have been recommending it. I'm not going to lie, I'm only about a third of the way through, but it's worth looking up. If not, just search for his name. He's got loads of talks online, or search for solid principles and you will find more than you ever want to read on the topic. The poster was there's a whole blog post of each of the principles inside motivational posters, if you really feel like decorating your office. And The layered approach, so I didn't actually reference this directly, like I say, is something that's used a lot in particularly web applications. To be fair, I think they work well there because they're fairly similar often, like there's some logic that changes, but they often follow the same pattern. And there's an idea called the onion architecture, which is sort of this layered approach on steroids, and talks about how dependencies should be related to each other and things like that, which might be worth a read if you're interested in that kind of thing. And I do blog. I've been very quiet this summer because I've been very busy, but I've got a lot of ideas around these concepts that I really want to put in there. A couple of tools for helping, so like with those spy objects, I've got a palette that really helps with that. So I'm hoping to put a few of those up over the next few months for some further reading on that. So dare I ask, are there any questions?
That's not, again, it's not a question really, it's a comment. When you've got your benefits, to me the prime benefit is regression testing.
Yes.
And that is actually the only benefit that would make me do it, and has cost me for not doing it.
That's interesting. So, yeah, actually, that's probably a bit of an obvious one to miss. The thing I'm wary of with pushing that side too much, but I think it is right. I mean, it's brilliant to be able to just run through it again and again. I do find that the things that are more often going to break are going to be covered by integration tests more than regression, more than the plain unit tests. But that's not to say, because the point of this.
I see the cycle of development being you get a bug reported, you make a change, then you run your set of tests to make sure you've not broken it, and that's the regression, and then the bug you put in. You know, that's the cyclic nature. I think, where for me it comes together.
Yeah, yes. To be fair, I was kind of thinking of that in this confidence bit as well. But yeah, you're right. It's the fact that each time you make a change, and I think the point I was missing now that I meant to say that isn't directly that, but it's related. I'm not just claiming that. Is a lot of these tools are about automation as well. So I didn't really talk about that. Obviously, every time you write a bit of code, you test it in some way, probably. You might integrate it to full application and kind of exercise that bit of it, or you might, just write a little test VI or just run it directly. But the reality is, call it lazy, call it want to get onto the next job, call it, whatever you want. If it isn't automated, if it's more than a couple of clicks, whatever best intentions we have, we probably won't do it regularly enough. And so the automation is a big part of that.
So I have something in practice that we had to implement 21 CFR Part 11 password rules into our application. You may not have, password must be at least 8 characters, may not have more than 2 repeating characters, must contain numbers, must do this, must do that. And testing all of this, you have to test for each of the characters that you are allowed and not allowed. And it's done with a touch screen, which isn't the most responsive thing in the world. And leaving our poor QA lady downstairs to go through the 1.2 million different iterations didn't seem fair. So we automated that and then just had to prove on the integration side that what she typed came through to the code, and then what goes into that code comes out as this: here's half a ream of paper, FDA, off you go. Take your pick. But that's what we've used it for. It wasn't to go in depth on anything, but just the level of automation that we could do that you couldn't do.
Yeah.
I do think pushing those data log files that I showed in mine as your data to drive your unit test. Because when I saw it,
yes,
I thought, ooh, because then you have a sweep of operation
of real life data. Yeah.
And actually working.
This is why I advocated the unit test framework so much before, to be fair, because I did really like with that, like I say, classes break it. Frankly, if you're using classes, it's more effort than it's worth. But if you're not using classes, it's so nice that you can actually pull up a VI, and I wonder if it will work with that data log anyway. At any point you can pull up a VI, you can open its test window, and you can say, right, all the values that are in that VI, those are the correct values, copy them over. And then it will redo it each time. And then when you started talking about that at the CLA summit, I thought, now if you could do that as well to build your test vectors, yeah, you could run it through, because that's part of the problem with human written tests is, like I said, they obviously only test what you've written. They don't necessarily hit realistic values if someone doesn't think that could ever really happen, which is normally where bugs come from.
Well, it's also the thing is with modular design, if you break down your modules to be cohesive and simple and small, and then you do your unit testing on the modules that's cohesive and simple and small, actually, even though you may say, oh, I've done all my modules, I've got 100% test coverage. Well, that's not quite true, really, is it? Because you haven't done how all the modules interact with each other, which is actually what your program is, and that's probably where the majority of the bugs come.
Well, this is it. It's one of the big things I've taken from my systems engineering course is, however complex a system is, it's the interactions between parts of it is where stuff will break more often than in it, and that's wI say, it's about tying things together, because that's where stuff will more likely go wrong. I think that's.
How often do you run your unit testing? Is it part of a night you build? Or
so right now in LabVIEW it's manual. I am hopefully a couple of weeks away from putting it into a CI system. So the JavaScript stuff, so to be fair, because I do my test first and I use tests as part of my development practice, I do tend to run them manually pretty regularly in whatever environment. And in JavaScript, what you tend to do is leave them to automatically run. So every time you make a change in your code, it reruns your tests. So you get very fast feedback if something breaks. With the JavaScript code, every time we push it up, it's retested on CI server, because, as I say, you can't trust yourself to remember to do it all the time. LabVIEW, that's difficult with the current tools. Been working on a couple of things to hopefully make it easier, and I'm hoping to start using that as well. Any other questions? I hope it was useful. I realise I covered a lot in a short time, and I wasn't quite sure where to cut it, but I hope it all tied together, and like I say, just shared some experiences really.